Good morning, everybody, or day, whenever you're watching this. It's Sunday morning right now, the 21st. And just real quick story, the sun's out and it's like 25 degrees and like minimal wind. So Winnie and I went for a walk this morning, and I just cannot tell you how good the sun is for you. Don't underestimate the power of the sun. I just feel so rejuvenated right now. Vitamin D is good for you. So if it's sunny and nice outside today when you're watching this, do yourself a favor and get out there for a little bit, even if it's just 10 minutes. It's worth it. I don't know. We need this. We need the sun, and we've just been missing it for so long. So you didn't need to know any of that, but do yourself a favor and get outside if it's nice out. So we are starting our next chapter. The heart of it is trig, but we start off with this other little lesson on geometric mean and similarities in right triangles. Kind of long story short, this whole chapter is about finding missing sides and angles in right triangles. So that's kind of why we can tie this lesson in with the rest of the chapter. Bear with me. It's kind of goofy. It's kind of weird. You might not like it. But that's that. So geometric mean and similarities in right triangles. Let's get rocking here. The first part's pretty straightforward because we've been working with proportions for the last while now, because that was all chapter 7 is blank over blank equals blank over blank, right? So we actually have names for our proportions, like the spots in which they're in. So you read this, A over B equals C over D. The first and the last one are called your extremes. And then the ones in the middle are called the means, and that's how I remember that, because middle starts with M and mean starts with M. So when you read this, A over B equals C over D, B and C are in the middle of that sequence, right? So those are your means because it starts with an M. But you have your extremes and your means. Now, when you're looking for the geometric mean, that's when your means in your proportion are the exact same. So when B and C are the same, we are able to find the geometric mean. So it says find the geometric mean of these two numbers here. So I don't want to use this color. Okay. So again, we're looking for the geometric mean. So that's when our means are the same. So I'm going to write 5 over x, because we don't know what it is. We're going to call it x, is equal to x over 45. Do you guys see how our means are the same? And now you've been doing this for weeks. Cross multiply. So x times x is x squared. 5 times 45 is 225. Now, it's been a while since we've worked with anything squared, because most of our stuff is linear, so this is quadratic. How do you solve something squared? Well, we take the square root in this case. And this is nice. We do get a nice whole number. The square root of 225 is just 15. So there we go. Now we're done. Okay, our next one. Again, 12 over x equals x over 15, x squared. 12 times 15 is 180. So now when we, in our calculator here, take the square root, can we see this, of 180? Oh yeah. We get a decimal. We're not going to be a fan of that. We don't want to have decimals in this lesson. So we have to break apart this radical. And now it's kind of, it depends how far you got last year in Algebra 1, especially with distance learning. You either know how to do something like this, or you've seen it, or you're going to learn something new on the fly, which is okay. Because I think everyone's going to need some type of review. So we have to figure out what perfect square goes into 180. So I could list the perfect squares real quick just on the side here. So remember, our perfect squares would be like 4, 9, oh boy, 16, 25, 36, 49, 64, 81, 100, 121, 144. Okay, we won't need to go past that, at least for this example. So we have to figure out which one of these perfect squares evenly goes into 180. So how I like to attack a problem like this is I'm going to take 180 and divide it by 2. and I get 90, right? So I know it has to be from here and above or below. So we want to try one of these numbers and see if anything evenly goes into 180. And some of you are going to be able to tell because you have really good number sense what number goes in there. And some of us are going to have to use our calculator. It doesn't matter. You do whatever works for you. I'm a big fan of calculators. So 180. And I like to start with the top. Like, do I know 81 doesn't go in there evenly? Yes, I do know that. But I check anyways because I'm weird. So that one doesn't work. What about 180 divided by 64? Nope, still get a decimal. 180 divided by 49, still getting a decimal. So we keep going. 36. Ooh, we love to see that. So now I know that 36 goes in here 5 times. Because remember with radicals, if I multiply those together, I get 180. This means the same thing. I just wrote it differently. We manipulated it to work for us, okay? So now what is the square root of 36? Well, we know that that is just 6. And then there is nothing that goes into 5. It's just root 5. So we reduced or simplified the square root of 180 to 6 root 5. Again, some of you have seen that. Some of you haven't. We'll work with it, okay? It doesn't really go away. You'll use it a lot in Algebra 2. So it gets easier, okay? Okay, but just big takeaway with geometric mean, we kind of got off track there. Your means are the same when you multiply in your proportion, and then we get our number. Okay, because now we're going to shift gears a bit, and we'll come back to this geometric mean in just a moment here. So it says, write a similarity statement for the 3 triangles. Well, holy cow. Here we go. Let's first off talk about, do you even see 3 triangles? Because that's step 1. I hope we can tell we have this big triangle, right? So I'm actually going to draw out my 3 triangles so we can see them all. Okay, here's F, E, G, and here's my right angle. So for this lesson, we're going to be talking about short, long, and hypotenuse a lot, okay? So let's start with the easy one. Our hypotenuse, remember, is always across from that right angle. So this side here would be our hypotenuse. So I'm just going to call it hype, okay? And now you kind of have to use your judgment, which I usually tell you to not trust a picture, but you kind of have to in these problems. So now we have either a short side or a long side that's left. And we can clearly tell that EF appears to be the short side, right? And it's probably easier on this picture. Like clearly EF is the smaller of FG and EF. So here's our short, so I'm going to put an S, and then our long would be this guy. Okay, so that's for one of our triangles. Now let's draw out HFG. So do you guys see this triangle here? I'm going to draw that one right here. So HFG. So again, start with your easy leg. That's your hypotenuse. That's the one across from that right angle. So here's our hypotenuse. Our short leg would be HF. So I'm going to put an S. And then our long leg would be HG. And then our final little triangle here is this guy on the right, right? Do you guys see that? So I'm going to draw this guy out. H, E, F. Again, draw your little line here. That tells us our hypotenuse is EF. Our short side would be EH, and our long is FH. So now when you do this, it makes writing your similarity statement much, much easier. So if we start with our big triangle here, you can kind of pick your order. But I think it's easiest if you pick your right angle, since every triangle has a right angle. So I'm going to start with my right angle, so that's F. And now you can decide where you want to go. Do you want to go short side or long side? Should we go long? So I'm going to write this so we know we went long, hypotenuse, short. So I went for my right angle, I'm going to the long side, so I hit G, crossed my hypotenuse, so I hit E. So now remember, in a similarity statement, everything has to match. So now on this one, we started with our right angle, so we have H. Now follow your key. Now we went to the long side, so I'm going to go H to my long side, which is G, up top. There we go. And then our last one here, start with your right angle. So we have H, go to your long side, so F, E. And I know some of you are way smarter than me and you wouldn't have to draw all this out and then do the little key, but I think it's helpful for this first time just for you to see like how we got what we got. Again, everything has to match. So that's why I drew it out long, hypotenuse, short. Okay, because now we have to use this hypotenuse long short idea with the geometric mean to help us find missing side lengths in right triangles, okay? Okay, here we go. Stick with me, bear with me. I really need to get rid of Adobe for the millionth time. Okay, here we are, folks. We are solving for the variable y. So if we look here, we have this little triangle, right? Do we see that, folks? This little purple one. And then we have our blue triangle. Okay, you guys see those? So now we have to label our sides on these triangles. So 4 would clearly be our short side on that little purple triangle. And y would be our long side, right? Because here's our hypotenuse, so this would be our long. Okay, so now we know we're working with short and a long side. Now we'll just make sure it's working the same on the big triangle. So y here would be our short, and 12 would be our long. Are you guys with me? Does that make sense? Because do you see how we know nothing about this hypotenuse here and this hypotenuse here? So I only know things about the short side and the long side, nothing else. So now from here, we can write a proportion to help us figure out what that y is. So since I made my key to be short over long, I'm going to start with my little purple triangle. It doesn't matter which one you start with. I'm just choosing to start with this one. I'm going to write 4, because that's my short side, over my long side of y, is equal to, now come to the big triangle. What's your short side? Y. What's your long side? 12. Okay, now again, kids, if you don't get something times itself either the same number or the same variable, you messed up. I don't mean that in a mean way, but that's just a good way to check yourself. You messed up, okay? So check yourself. I'm taking y times y, so I know I must have done something right. So we're going to have y times y, which is y squared. 4 times 12 is 48. Take the square root. Well, we know that 48 is not a perfect square, so we're going to have to break it down. So you're thinking, okay, what number's in the sheet? Okay, let me find it. I just threw it. Okay, let's look at our numbers here. Which one of these numbers is evenly going to go into 48? I hope you're thinking 16 because that's it. So how many times does 16 go into 48? 3 times. And now we can break it apart. So the square root of 16 is 4. We don't know the square root of 3, or it's not a nice number, so it's just 4 root 3. Yes, that is what we just did. How do we feel about it? Okay, we're going to do one more, and then we'll leave the last one for class, okay? So we kind of have a lot going on here. We have 3 variables we're looking for, E, D, and C. It's always easiest if you start with the middle one, in my opinion, if you're able to. So let's first find E. Okay, so I'm going to have E right here. So if I look on this left triangle here, 6 would be my short side. E would be my long. So we're hopefully going to use short and long. Okay, that's our key. That's telling us what to do. And then this triangle on the right, you guys see that? E is our short side and 24 is our long. Okay, so now let's write our proportion. So we start on this triangle on the left. Our short side is 6. Our long side is E. Come to the big one. Your short side is now E. Your long side is 24. 4. So again, check yourself. Do we have the same thing times itself when we cross multiply? We do. We get e times e. So we get e squared. 6 times 24 is 144. Woohoo, this is a nice one. Take the square root. What's the square root of 144? That is just 12. So there we are. That wasn't so bad. Okay, now it's kind of your choice. Do you want to find C or D? It doesn't matter. Should we find D? That works. So what's nice here, kids, is you could do the geometric mean, which would be super. Or since now that we know that this side is 12, we can just do the Pythagorean theorem, right? Because it's a right triangle here. That's your hypotenuse. So you could do 6 squared plus 12 squared equals D squared. Oops, can't see that. There we go. Again, we just have a right triangle right here. We know 2 of our sides, so it makes more sense to do the Pythagorean theorem because it's easier, right? We already know how to do that. So 6 times 6 is 36. 12 squared is 144 equals D squared. 36 plus 144 is 180 equals D squared. And luckily for us, we just simplified the square root of 180 in that previous example. And we know that 36 goes in there 5 times, which just ends up being 6 root 5. There we are. That's D. And then our last one here, C. Again, we have this triangle here, this green one. We know 2 of our sides. We're just looking for a hypotenuse. So again, it's going to be 12 squared plus 24 squared equals C squared. Twelve times 12 is 144. 24 squared. What is 24 squared, you guys? 576 equals C squared. Add those together, get 720. Take the square root, which isn't a nice number, so we kind of have to think outside the box. 720. What's going to go into 720 nicely? Well, what's 720 divided by 2? Excuse me, guys, brain fart. 360. So that kind of works. So we could do that. So let's take 720 divided by 36. And we get 20. Okay. So now from here, we know the square root of 36 is 6. But we can still break apart 20, but that's okay. We made it easier, like more manageable numbers by doing it this way. So what now perfect square goes into 20? Well, we know that 4 does 5 times. What's the square root of 4? It's 2. We don't know what the square root of 5 is, or it's not a nice number. And now we simply just finish by multiplying. 6 times 2 is 12. So 12 root 5. Okay, I know this probably got long. I know you're probably confused. We will do the last example together in class. We'll probably do all of our homework together. Do not fret. Thank you for watching the video if you've made it this far. Have a super day, and I will see you in class next. So, adios, amigos.